Hello everyone. This is a review for unit test number 5. This is an instance of problem set 5, and as you should know, to prepare for unit test 5 you must take problem set 5, and the goal is to score at least 50% before you take unit test 5. So getting to the questions, question 1, factor the greatest common factor. So when we have, in this case, two terms, we're going to compare term by term the coefficients and the powers on the variable. So the greatest common factor between the coefficients is 4, because 4 is the largest number that divides evenly into both 4 and 24. And when dealing with the variables, remember it's the least common power. So what between y to the 8th and y to the 5th, y to the 5th would be common. So to complete the factorization, we'll write down the greatest common factor for y to the 5th. Open up a set of parentheses and basically reverse the distributive property. So to generate the first term, imagine multiplying 4 times what to give 24, and that would be 6. And then we need 8 factors of y. We have 5 of them factored, so therefore we need 3 more. So 6y cubed to generate the first term. Then we could put the minus down, and to generate the second term, thinking of reversing the distributive property, looks like all we need is a 1, because everything is common. So therefore, getting rid of the clutter, 4y raised to the 5th times the quantity 6y cubed minus 1 would be the complete factorization. Okay, second question. Remember, when we're dealing with a quadratic trinomial, it's generally factorable into the product of two binomials. So x plus 2 and something. And our binomial here, you could think of reversing the FOIL method, or remember, if the leading coefficient is 1, coefficient of the squared term that is, then you could look for the factors of the constant term that combine to give you the coefficient of the linear term. And so if you wanted to, you could say we'll list the factors of 6, and we'd have 1 and 6. We also have to consider negative 1 and negative 6, 2 and 3, or negative 2 and negative 3, and then we're looking for the pair of factors that combine to give us a positive 5. So that would be the positive 2 and the positive 3. Now also, I like to, as you've gathered from previous lectures, think about reversing FOIL. So I know it's plus 2 and I know it's a plus 3 here, but let's think about, let's say we don't know that. To multiply the first terms to give x squared, we need an x, but then the outer product and the inner product have to add to give us 5x. So if we put a positive 3 here, the outer product gives us 3x, and the inner product gives us 2x, which combines to give us the 5x. And then we could check to see that the last terms multiply to give us the constant 6. So the correct factorization, x plus 2, x plus 3. Alright, there we were given the hint that x plus 2 was one of the factors. Now we want to just be able to do this without being given the hint. So we know a quadratic trinomial is factorable into the product of two binomials, and if the first term, the leading term, is just x squared or a squared or whatever variable we're dealing with, that is, the coefficient is 1, we just need an x and an x. And then you could use the factor method, or you could reverse FOIL. Using the factor method, again, we're going to list the factors of 6. So positive 1, positive 6, negative 1, negative 6, positive 2, positive 3, negative 2, negative 3. And the pair that combine to give us positive 7, the coefficient of the linear term, is 1 and 6. Now, also you could do the trial and error method. So let's say you were to, I'm going to do this wrong. Let's say you know for sure that since everything's positive, that these must be positive. And let's say you guessed at 2 and 3. And this is wrong, but I just want to illustrate the guess and check method. The inner product is 2x, and the outer product here is 3x, which combines to give us 5x, and that's not what we're looking for. We're looking for 7x, so that's not the correct factorization. So that's why if we do the x plus 1 and x plus 6, the inner product gives us 1x, the outer product 6x, which adds to 7x. I like to usually put a double line there when I'm adding the terms. So that's the correct factorization. Similarly here, we know it's the product of two binomials again, x and x. Factor method works nicely. So the factor is 56. So now we have a bunch of choices. It's usually not the extremes like 1 and 56 or negative 1 and negative 56 or 2 and 28 or negative 2 and negative 28. Let's see, you can go down the list and even use a calculator if you need to. 3 is not a factor of 56. 4 is, so 4 and 14 or negative 4, negative 14. We're looking for the pair that adds to give us negative 15. So let's see. Next factor would be a 7 actually. 7 and 8 or negative 7, negative 8. And there it is. Because negative 7 and negative 8 combine to give negative 15. So x minus 7, x minus 8. You could do the little check here. There's the inner product, minus 7x. The outer product, minus 8x. Combine to give minus 15x. And that checks. Okay, sometimes they're easier. That one was a little more exhaustive, but for example here, knowing that, again, the product of two binomials with an x and an x, let's think about the trial and error method before we look at the factors. The constant term is just a 5 and it's negative. So one of these has to be positive and one negative. That's the only way we're going to multiply the last terms to get a negative number. And there's really only one choice. Here, if you want to use the factor method, factors of negative 5 are just 1 and negative 5 or negative 1 and positive 5. And to combine to give a negative 4, we need the 1 and negative 5. So the 1 should be the positive and the 5 the negative. And then you could do the check. Positive 1x for the inners, negative 5x for the outers, combines to give us negative 4x, and it checks. So trial and error, factor method works wonderfully, but when the leading coefficient is not 1, that's when we have to think about trial and error. So continuing, again, a situation where we have two binomials, x and x, for the first term of each. Once again, since the constant term is negative, we know one is positive, one is negative. Doesn't matter which way you put it, the positive and the negative, just got to get the numbers right. And then a lot of times, like if you want to make a guess, two numbers that multiply to give 72, but that combine to give a positive 1, because the coefficient of that x term is just 1. It's going to be two numbers that are kind of close together, so it strikes me as an 8 and a 9 if you're just kind of thinking without listing the factors. And if we make the 9 positive and the 8 negative, that's going to work. And again, you could use the factor method. So the factors of a negative 72 are 1, negative 72. Again, it's usually not these extreme ones, but it could be. Negative 172, 2 and 36. Let's say negative 36, or negative 2 positive 36. See, 3 works, right? No, it doesn't. 3 does not divide evenly. 4 divides evenly into 72 18 times, so 4, negative 18, negative 4, 18. 5 doesn't work. 6 works. 6 and negative 12, negative 6, positive 12. See, we're still not there. So now we get to the 8 finally. 8, negative 9, negative 8, positive 9. And the ones that combine to give us a positive 1 are the negative 8 and 9, like we concluded using the other method. Then if you want the check, inner product plus 9x, outer product minus 8x combines to give us positive 1x, and it checks. Now, if the leading coefficient is not 1, the first thing we look for is the greatest common factor. And in this case, there's a negative. So we first factor out the negative 1. So factoring out a negative 1, now we're just doing greatest common factor, so we're reversing the distributive property. It basically just changes the sign of each of these terms, because a negative 1 times a positive r squared gives a negative r squared. A negative 1 times a negative 21r gives a positive 21r. And a negative 1 times a positive 38 gives a negative 38. So that negative 1 is part of the factorization. But then we can go further, because now we have a quadratic trinomial, which we assume is factorable into the product of 2 binomials. And since it's r squared, just like when we have x squared, we'll use x and x. If it's r squared, we'll use r and r. If you want the factor method, factors of 38, and 38, negative 1, negative 38, 2 and 19, negative 2, negative 19, and looks like that's it. And the pair that combines to give a negative 21r is negative 2 and negative 19. And then if you like, you could perform the check. Minus 2r minus 19r for the inners and outers respectively, combining to give us minus 21r. Okay, here's another example. See, it's a quadratic trinomial. Again, possibly factorable into the product of 2 binomials. Looks like we'll need an a and an a. And if we want to use the factor method, we're listing the factors of positive 16. Should be a negative 1, negative 16, positive 1, positive 16, 2 and 8, the negative 2, negative 8, and finally 4 and 4, and negative 4, negative 4. And then we're looking for the pair that combines to give negative 8, and that's 4 and negative 4. And here's that special situation where the binomials are the same, and you could leave it that way, but if you like, you could also say it's that binomial as a quantity squared. You could perform the check on that yourself if you like. Alright, getting to page 2 of this review. Don't forget about the special products. Here we don't have a quadratic trinomial. We just have a binomial, but it's quadratic because it's squared. And remember the difference between two perfect squares. That is, a squared minus b squared is factorable as the product of a minus b and a plus b. So when you see just two terms, the middle term is missing, first check to see if it's a difference, and check to see if the two terms are perfect squares. Now, just setting this up without, I'll show you both ways as I've shown in the past, but the perfect square of 25x squared is 5x, so we need a 5x and a 5x. Now one is negative and one is positive, doesn't matter which way you put them. The perfect square of 4 is 2, so a 2 and a 2. And then you could check, you could perform the complete check and literally FOIL, or just check the inners and the outers. And you could see that the inners give negative 10x, the outers exactly opposite, positive 10x, combine to give us 0 or 0x if you like. Now, the other method is to think of, I'll put or here. I think this is more difficult to think of it this way, but if you like, you could think of it as 5x squared as a quantity squared minus 2 as a quantity squared, where it's fitting the form of a squared minus b squared, and then complete the factorization according to our special formula. So if you like it this way, that's fine. But I think it's easier just to think of the concept of the difference between two perfect squares. Now here we have another case where there's just two terms, and you see a difference, and they're actually both perfect squares, but the first thing we need to look for is the greatest common factor. Now between 16 and 256, 16 is actually common. You might need a calculator to do the 256 and do divided by 16 to see what that is. And it's 16. So 16 is common, and between the variables, we would factor out the x squared, smallest power, remember. Okay, so we're going to reverse the distributive property, write down the greatest common factor, 16x squared, to get the first term. We're just missing two factors of x, so x squared, to get the second term. As we did on our calculator, 16 times 16 is 256, and we don't need the x squared, it's already factored. And now 16x squared is part of the factorization, but now we should recognize x squared minus 16 as the difference between two perfect squares again. And it looks like this one's nice and easy. Do an x and an x, 4 and a 4, make one of them negative and one positive. Alright, continuing with letter I here. Looks like we've got a quadratic trinomial with leading coefficient of 7. So check for greatest common factor, and it is 7. So reversing the distributive property, to get 7x squared, we need an x squared for the first term. You can write down the plus to get 28x. We need 7 times 4 is 28, so 4x. And to get negative 84, we could write down the negative. Use your calculator if you need to. 7 times 12 is 84. And then 7 is part of the answer, but now we could factor the quadratic trinomial that remains. Use an x and an x, and I'm just going to do the factor method real quick. Factors of a negative 12, 1 negative 12, negative 1 12, 2 negative 6, negative 2 6, and Don't forget about 3, negative 4, negative 3, 4, but it looks like the one that combines to give a positive 4 is the negative 2 and the positive 6. So x minus 2 and x plus 6. Okay, again with letter J. The leading coefficient's not 1, and definitely here you see the powers on the variable. It's not your standard quadratic, so you know greatest common factor. And 4 does divide evenly into each of the coefficients, and the smallest common power is the third power, so 4t cubed. So we'll write down the greatest common factor, 4t cubed. Okay, we're just reversing distributive. You can always think of division, like 4t cubed divides into 4t to the 5th. I think reversing multiplication is easier. We need a t squared. To get 24 from 4, we need a minus 6, negative that is. Looks like we're missing one factor of t there to get the second term, and then to get our third term. Okay, it's positive. 4 times 8 is 32, and we've already got the t cubed factored. Alright, so now 4t cubed is part of the answer, but the remaining quadratic trinomial looks to be factorable into the product of two binomials, where we're going to use a t and a t. And I think I'll do the factor method again. Factors of positive 8, 1, 8, negative 1, negative 8, 2, 4, negative 2, negative 4, and that's it. And the pair that combines to give us the negative 6. Coefficient of the linear term is negative 2 and negative 4. You can perform the check if you like. Alright, now here's a situation where we have to use trial and error because the leading coefficient is 2 and nothing is common. So trial and error, alright, we're reversing the FOIL process. So to get a 2x squared out of the product of the first terms, we're going to need a 2x and an x. Now what we could do is force the last terms. And I'm going to choose to do this wrong. And the last terms, fortunately here, the last term is a negative 13. Okay, so I know one is negative and one is positive. And fortunately, there's only two factors of 13. 13 and 1. So let me slide the 13 in there and the 1 in here. And see the product of the last there gives us the negative 13. But now let's check the inners and the outers. If we check the inner product, do it this way with the red, that's negative 13x. The outer product is positive 2x. That combines to give negative 11x, and that's not what we're looking for. So that's the wrong factorization. But what I could do, because the choice is really, that's all we have is 2x and x, 13 and 1. But what we could do is switch the 13 and the 1. So 2x and x, make it 1 with the 2x and 13 with the x. Alright, let me leave them as negatives and positives. And let's do the check of the inners and the outers. We get negative 1x, positive 26x. That combines to give us positive 25x, but we're looking for a negative 25. So all we have to do at this point is switch the signs. So 2x plus 1, x minus 13, and then it's going to work. Positive 1x for the inner, negative 26x for the outer, negative 25x, which checks. So there's our correct factorization. Alright, and number 4, they give us some hints. So here we're reversing the FOIL, and the hints help quite a bit because, in the last example we had to generate all terms on our own. Here they give us 5x plus 9. So the only way we can multiply to get 5x squared here would be an x. And since everything's positive, we know this sign is positive. And the only way we can multiply the last to get 27 would be to put a 3 in there. And then we could check that that works, because here's the inner plus 9x. Here's the outer plus 15x combines to give us plus 24x, and it checks. Okay, so pretty much the same concept here. We're given 10x minus 1 is a factor, and to multiply the first to get 50x squared, we're going to need a 5x. Now we know that since the constant term is negative, this is a negative 1, so this has to be a positive. But see, we only have one choice here, because the only numbers are 1 and 3 to multiply to give us the negative 3. And then we could check the inner and the outer product again. Get negative 5x for the inners, positive 30x for the outers, combined to give plus 25x, which checks. Okay, we'll do the next one, and then we'll stop the video and do a part 2. The next one is a factor by grouping. That's when we have 4 terms. So when we have 4 terms, what you want to do is write down the first 2, x squared cubed plus 2x squared, draw a line, and write down the second 2, plus 6x plus 12, and write down the sign as well. And then factor the greatest common factor from each. The greatest common factor from each pair, I should say. From the first pair is x squared. So if I factor out the x squared, we're just reversing, we're covering this part up, we're just reversing the distributive property. To get x cubed, it need an x. To get positive 2x squared, just a plus 2. And do the same thing here. Greatest common factor from this pair is the number 6. And it's a positive 6, and I'd suggest you write down the plus 6. And reversing the distributive property to get 6x, we just need x, and to get positive 12, we just need plus 2. And notice how the x plus 2, that binomial is the same. So if you factor them up, you can do the cover-up method. You can see what's left over, x squared plus 6. But the point is, x plus 2 is common. And then the leftover factors are x squared plus 6. Okay, so we'll stop the video right there. We'll do a part 2 for this. And so we'll see you when you're ready, and we'll solve a bunch of equations.